Well, good morning. Good morning, Mr. Vinod. Welcome to
Hey, good
India
evening.
virtually again. So, Del, we had wonderful day today. We had excellent participation from government. Telangana government, they were like first state in the country to put policies for data center. They have put several things, and they would definitely consider our ECBC user guide to have some implementation in data centers in Telangana state. I'm happy to mention that Ministry of Environment, Ministry of Electronics and Information Technology, from where we had Srimati uh, Uma Chauhan, who is Director for Ministry of Electronics and IT, and looking after the data center policy. She has agreed to have a lot of recommendations considered for this data center policy, which we have submitted as part of AGM. Also, there would be a lot of discussion ongoing after this data center summit, how we can put our best efforts for data center policy. She has especially given thanks to LBNL for providing all the feedback and recommendation. This is for your kind information. Okay, so today's we have a very good session, and now we are having another good session on case study presentation, which is very important for India, because till today there are very few case studies available on like little part, but now IGBC and LBNL has developed a lot of case studies. One is already out for all the stakeholders, and the another case study which we are having from NetApp, it is particularly a case study just to showcase like how data center can adapt free cooling, because they have demonstrated like it gives lot more benefits to data centers. So let me introduce our first speaker, Mr. Vinod Kulkarni. So, Mr. Vinod Kulkarni is a facility manager at NetApp Bangalore campus. He's an electrical engineer with 30 years of professional experience in various fields like machine tools, FMCG, industrial refrigeration, corporate real estate and facility management, data center design, execution and management, which is like his core expertise. He is the internal auditor certification for information security management system from STQC, internal auditor certification for QMS, EMS, OHSAS from Bureau Veritas, internal auditor certification for QMS, EMS from DNV GL, Six Sigma Green Belt certification on reduction in UPS, downtime, and energy conservation. He has international exposure on several fields, but we are running slightly late. I would request Mr. Vinod Kulkarni to please present the case study on free cooling. Thank you very much.
Hey, good evening. This is Vinod Kulkarni. Hope you all can hear me.
Yes, sir. We are able to hear you.
Yes. I'm part of NetApp from last more than 11 years now. NetApp is basically a data storage management company, and we have a campus in Bangalore on the way to Whitefield. So I'll be presenting a case study on NetApp data center. What are the unique things we have done in the campus, along with the airside economizer for the data center. Shiraj, can I start sharing my screen?
Yes, please.
Yes.
Please share it again.
Yes.
Yeah, perfect to go.
Yes. Basically, we were in lease location before we built our own campus, and no, in the lease location we had many issues, and our energy efficiency was very low. We used to run around 1.8 or 2 PUE. So when NetApp decided to move to its own campus, they wanted to do few unique things out of the industry standards, over and above industry standards. So NetApp management supported that, and when we completed the campus, it come out very well with very unique things about the industry standards. So few things I'll be taking you through the very unique salient features of the campus. So agenda for this meeting is campus, with reference to NetApp Bangalore campus certifications and recognitions, what we have, what NetApp has got, and sustainability and conservation efforts at the campus and data center. With a reference to data center, and we also call it as a lab. Basically, it's a part of lab and part of data center. So what all the unique innovative design and things it has been adopted at the data center, as well as the with reference to operations, how we are managing the existing data center. So this is how our data center looks from the outside with a bird's eye. So one is the when the day we completed the data center, we applied for the IGBC green building certification, and it was qualified for the platinum certification. That is the highest certification. Successfully, we completed the we met the requirements and completed the requirements and obtained the certification. As well as this is with reference to design, and with reference to the implementation of the environmental management system, ISO. So we went for ISO 14001 certification with 2015 standards. That is the latest standards, and we were successful in getting the certification for the management systems with reference to our operations. So with what are all the sustainability and conservation efforts at the NetApp campus? With reference to energy, we have on-site solar power generation. It's a very small, even though very small, we have it, whatever the space available on the terrace, we have installed solar panels. So almost on a daily basis, it generates 160 kilowatts, and this power is directly connected to the ring mains. It's not dedicated for any particular load, so that entire power generated gets utilized at the solar energy gets utilized to the maximum extent. Then over and above this, we also use off-site renewable energy, basically from the wind and solar, as well as mini hydro. We always ensure that more than 75% of the energy consumption comes from the these renewable sources. And energy efficient, with reference to lighting, we have very energy efficient PoE, that's power or Ethernet sensors based office lighting system. And 100, what I can say, it's 100% LED fixtures with the intelligent LMS, that is lighting management systems, for efficient control and maximum daylight harvesting, as well as the end user comfort. Means always the end user gets the lighting level which is required at his desk. And we have Droops, that is flywheel based UPS system. It's 100% batteryless, highly efficient, highly energy efficient generator, UPS, and IP bus, IP bus to give the maximum redundancy, as well as the energy efficient. And what I can say is, NetApp Bangalore campus is entire campus is 100% loaded on the UPS. And entire campus is supported with the UPS. And we, for the airside economies, that is the main point of the discussion. Airside economies are a free cooling arrangement for the lab. Our data center, best in the industry. Our average PUE always below 1.3. Even the design is 1.3, because of various conditions and requirements. Some of the entire lab is not loaded fully, even though part load or half load or 70% the load, the efficiency remains same. We always run below 1.3 PUE. And electrical vehicles charging points are provided in the parking slots wherever required, wherever it's required, and whoever comes with an electrical vehicle, they can use these charging points free of cost. With reference to water conservation, what we call it as zero discharge site. This campus is zero discharge. We don't discharge any water or recycled water, anything outside the campus. All the water is recycled, treated, recycled, and basically this goes for the landscaping. Anything, if the water remains over and after the using it for landscaping, it is used for reflushing as well as the HVAC application. And rain, we have whatever the rainwater, rain happens on the campus, everything is collected and stored in eco pond and utilized wherever it can be. And automated and sensor based plumbing systems to minimize the wastage as well as the maintain the hygiene. There is no need to touch any of the plumbings. Everything is automated, everything is sensor based. And with reference to waste management, scientific waste management and disposal systems have been adopted, and we always ensure that more than 85% of the waste is recycled. We have an arrangements, a few arrangements with an NGO who comes and collects and ensures that it is reused, and he also shares the required document to ensure that it is used, utilized, or recycled and utilized. And coming to the data center design, innovative design and operations, NetApp Bangalore campus, which is on the and the way to Whitefield, has been built to the standards of Global Dynamic Lab. Basically, these are the tech center labs which are located in east and west coast of the US, and NetApp, east and west coast of the US. This Bangalore campus data center almost meets the requirements of the GDL lab, what we call it as GDL lab. So, a few unique things about this lab, it has got contained cold aisle with automatic, and access control doors. I will come to this point why this, automatic controls, and automatic and access control doors have been installed for the cold aisle, which is a contained cold aisle, vertical configuration with the ductless airflow. So there is no duct. The AHUs are directly sitting on the cold aisle. See, the lab is located in the second floor, and the air handling units are directly sitting above the cold aisle containment and throws the air directly into the cold aisle. There is no duct, there is no air loss happens in between. And also with reference to these access control doors, in the older labs, when we are in leased location, we always used to face these issues. The end user or the lab, data center user, whoever comes inside, maybe it used to be manual doors. They never close these doors, and we used to face a lot of energy as well as the air losses. So these doors are access controlled as well as automatic and sensor based. Someone going inside, the door closes automatically. Someone coming outside after the set time, the door closes automatically. And we have campus has been supported with the water cooled chillers for our lab as well as office usage. For the higher efficiency, and AHU fans are now built with easy fans and VFD drives. This helps us to achieve the maximum efficiency depending on the load at the cold aisle containments. And we have installed airside economizer with the motorized and automated dampers for the maximum efficiency. And this entire process of using the external air is controlled through an intelligent IBMS system with a minimum or no manual intervention. Electrical load, these are all the base highlights of the lab. Electrical load, again, supported by the flywheel based generator, UPS and IP bus configuration, which to give the maximum redundancy, energy efficiency, as well as the meeting the environmental standards where the battery is absolutely, it's a zero battery or no battery. And when you install the battery, go with standard old design of UPS. You need to provide the cooling arrangement, the fat batteries. It occupies huge space. Maybe for our capacity to occupy huge space, all those things have been avoided. And power is distributed through modular Starline busway system. It's a very modular. Wherever you require a load, it can be moved. And intelligent and network PDUs have been used to ensure that precision control as well as the monitoring. Entire monitoring of the power consumption happens through the networking. It records each and every minute's consumption. So with all this, innovative designs, so designed the innovative installations. The design PU, when we thought of building a new lab at our campus, we thought we'll get around 1.3 PUE, but operational PU is running at less than 1.3 or 1.8. Average PU is around 1.8. So this is the brief chart how we are getting with reference, say, from last 8 to 10 months. Our IT equipment load, it shows, the graph shows IT equipment loads as well as the utilities load. So from this chart we can see in our PUE never crossed 1.3. This is how arrangements have been done. This from the externally, it looks like this. The lab, the data center is located in the second floor. So backside of the building, in the second floor, the lowers have been provided with fresh for the fresh air intake as well as for the exhaust air, hot air exhaust. This picture shows contained cold aisle with access controlled and automated doors, which I was talking. So each cold aisle can be restricted to, or it can be open to all the users, or if any confidential requirements are there. So access control, with the access control doors, we can give the access control rights to restricted people, so that we can avoid any further issues in managing these data centers. Again, the Starline by electrical distribution happens to the Starline modular. These electrical boxes can be moved anywhere the load. If there is a extra load requirement in any particular LAC, we can provide additional electrical, just moving these electrical boxes. As I was talking, the data center is located in the second floor, and third floor, just above the data center, the third floor, we have air handling units. And air handling units are directly sitting on the cold aisle containment. Absolutely, there is no duct involved anywhere, and the hot air comes back from the floor cutouts into the air handling units. And as well as for the taking the free air, we have plenum arrangement and the motorized dampers. We can see in the photographs, it's a huge plenum just running above the entire ceiling of the third floor. And with reference to the motorized, with the motorized dampers, whenever the set conditions are met with the IBM BMS system, the dampers will open and close automatically. This is just a screenshot of the free cooling in operation. So there are 3 options available: free cooling, partial free cooling, as well as the normal free cooling. When we captured this photograph, it was absolutely on the free cooling mode with the PUE 1.24251, and all the lab AHs are in running condition. With this is a screenshot of the BMS system. This is how arrangement has been done, the graphical representation of the free cooling and partial free cooling, as well as mechanical cooling arrangement.
So, Mr. Vinod, thank you very much.
Yes.
I think it was a wonderful presentation, and it is not the presentation. Your data center is like extremely well managed. About like 1.5 years back, we have visited your data center. We had good meeting with you, and fortunately at that time we had Dell also with us. We had like a
Yes.
good discussion at your campus. So this case study is already ready. You have given like lot of good insights. I believe like it is one of the best data center in India, which is using free cooling, maintaining the lowest PUE, and having lot many innovations. And the site where you have put like best and best efforts for like upkeep and excellent operational maintenance. Thank you very much, and congratulations to you for doing these best efforts in NetApp campus.
Yeah, thanks, Shivraj, for giving us an opportunity to present the NetApp case study. Maybe we'll thank IGBC and CIA for giving us an opportunity to showcase this our efficient lab. So if there are any questions, we are ready to take, or we can close this.
Sir, we will have question answer at the end of the session.
Sure.
Now I would request Mr. Del Sarter to have closing remarks because we had wonderful day one, great presentations from several data center leaders and domain experts. I will just introduce there because there are different participants for the day one as well as day two. There could be some overlap also. Del Sartre is professional engineer, is a staff scientist, engineer at LBNL, where he focuses on building efficiency technology applications. He leads projects to develop and transfer new technology and stimulate the use of underutilized technologies. He has over 40 years of professional experience in energy efficiency and renewable energy applications, including 10 years as a principal of an architecture and engineering company and 7 years as the head of the LBNL in-house energy management program. Currently, Dell is focused on R&D on energy efficiency in building for high-tech industries like laboratories, clean rooms, and data centers. Dell has internal experience. Dell has contributed a lot to Indian data centers to achieve a new level for energy efficiency. Over to you, Mr. Dell.
So thank you, Shraz. Are you seeing my screen?
Not yet.
Uh-oh. Now?
Good to go. Thank you.
All right. Well, thank you for attending the the summit and making this such a successful endeavor. Also like to thank CII for their organization and production of the summit, and of course the speakers such as NetApps demonstrating international leadership in energy efficiency. I also want to thank again our advisory group and especially the committee chairs that led the effort in developing the user's guide. And I want to talk a little bit about next steps and actions. The first one, of course, is to encourage the use of the guide and widespread distribution to adopt best practice targets, follow the recommendations in the guide, and then utilize the resources that are provided. And then following the use of the guide, please provide feedback to CII and the Bureau of Energy Efficiency and LBL. We hope to see the adoption of higher target levels, including level 2, which is a stretch goal, and level 3, super efficient recommendations. We'd like to see these recommendations adopted into the IGBC and in the future revisions. And we'd like to see the requirements or the recommendations integrated into the IGBC's Green Data Center rating system. The guide will allow, and we hope to see the recommendations used as a guide for achieving international best practices. And as companies adopt the standards as, say, a corporate standard, that's really going to be a sign of success. And we've already seen some companies starting to use the recommendations. We hope that you take advantage of the Indian case studies that support the guide recommendations, such as the last one we just heard from NetApps, but also already completed is one from Infosys, and additional case studies are expected down the line soon. Lastly, we are happy to hear that recommendations have been made to the Ministry of Electronics and Information Technology, and we hope to see follow-up there in the development of data center policy for India. As we've seen in the presentations on the various chapters, there's really no silver bullet in terms of optimizing energy efficiency in data centers. It requires a holistic approach with very strong commissioning to make sure that the operation meets design intent. And also, as we've talked about, the design guide addresses operational best practices such as IT hardware and software, air management, environmental controls, and the optimization definitely requires the best practices in the operation as well. as the design of the data center. So what are the next steps in getting started in your data center? Well, the first step is to get IT and facilities staff talking and working together as a team. Install monitoring systems that measure key performance indicators like PUE. Adopt and work towards performance targets, utilizing a continuous improvement process. And then as you have lessons learned, share your lessons with the rest of the community so we can see a general increase in energy performance and a reduction of our carbon footprint. So with that, I think we can go to the Q&A. Thanks, Shiraz.
Thank you, Del. We have received a couple of questions. First is for you. Which containment is best, whether hot containment or cold containment? This is a question from Mr. Prakash Lohiya, Senior Vice President, Reliance Industries Limited. And then further, he has mentioned, how do you manage servers when servers are having different airflow, like taking air from front and then having exhaust on all sides?
Well, I think that in some cases in retrofit, it's easier to retrofit a cold aisle containment arrangement. But if you're starting from scratch, as data center temperatures rise, it's probably better to contain the hot aisle. Otherwise, the data center is going to be too hot to work in. So we want to make the hot aisle a small and only needs to be occupied under at certain times. So anyway, I think that the hot aisle containment is slightly preferable, but they're both very good and a requirement basically for a high efficient data center. In terms of IT equipment and front to back, I mean, Reliance is a leader in terms of retrofitting poorly designed IT equipment, and we're hoping that the IT manufacturers will pay attention to the guide, and as users such as Reliance insist on front to back configuration, that will help to drive the market towards that configuration, because it's a real challenge when we have IT equipment that doesn't follow that convention.
Great. And Del, I think this is a problem about like week back. Again, we had some detailed discussion with Reliance team. Maybe I will connect you again after like week later or so. There are some new servers they have received for like 5G, and there are more and more problems. So we will discuss on that. So we have another question for Mr. Vinod Kulkarni. Let me read out that.
Sure, Raj.
Yeah. So he's asking like at this moment you are having full free cooling, partial free cooling, and then mechanical cooling. I think you have achieved some 20% free cooling at this stage. What happens if temperature is further increased by a half degree and 1 degree in steps? How much energy you will save? This is a question from Rushal Jha, Sales Manager.
Yeah, Shivraj, see, we discussed this, in the last meeting also when we were designing the standards. See, directly you cannot compare an Indian data center free cooling arrangement with the US or Netherlands, or people are coming up with the data centers in Iceland also, where you can maybe throughout the year you can get the 100% free cooling. In India, it doesn't happen normally. So best month for free cooling is, say, starting from October, November, December, January, to an extent January also. But 100% 24 hours free cooling doesn't happen in India. It happens maybe other countries. In India, maybe in the winter, good winter, even as well as the RH should be in control. If you have a best temperature, but if the RH is high, you cannot get you cannot use the free cooling at all. What happened to us in the last 15-20 days? The temperature was good, but RH was very high, above 80-85%, and you cannot use the air, outside air. So normally, as in a NetApp, if everything meets our standard, in the winter months we get about 10 to 12 hours of free cooling, and partial free cooling runs for a few hours. When the day breaks, maybe around after 10 o'clock, we automatically system moves to the mechanical cooling. It doesn't happen. You cannot compare just this data center free cooling arrangement to the US or other countries.
Yeah, thank you very much, Vinod.
We discussed in this detail. Free cooling arrangement, don't think that you will get 100% free cooling throughout the year. It doesn't normally happens in India. If you get a 12 hours after of 24 hours, it's very good. We can consider it as very good free cooling arrangement.
Great, thank you. I appreciate your answer. Now, next question is to Dale. Dale, Rushan Jha has put one question. Is there any provision for corrosion control system? As because of rising pollution level, ESRE recommends G1 level of corrosion. Would you be interested to reply it?
Sure, I think that would be a good question for both of us. But typically, a lot of the pollution can be filtered out. We did studies at actually at NetApps in their Silicon Valley data center and found that a MERV 13 filter would do the trick. In certain locations where you probably shouldn't build a data center in the first place, you might find some gaseous contaminants. Gaseous contaminants are going to impact the data center that has that either uses outside air or doesn't, because it's gaseous. It's going to get into the data center. But there again, I mean, there are filtration systems that can be utilized, but then there's going to be a trade-off between the cost and operation of the filtration system and the energy benefits. But except for a few locations, generally filtration can accommodate the air pollution issues.
Sorry. There are many questions, but we will take up only two last questions. Mr. Hemant Rajput, who is like regional manager at Infosys Limited, he has asked one question. What is DRUPS UPS batteryless? What is called? Could you please explain, Mr. Vinod?
Yeah, this is a very good question actually. So as a software company, as a data center company, NetApp, our team took little extra risk, or what I can say risk, by instead going ahead with flywheel based technology instead of standard monolithic or standard practice of having a UPS, huge UPS supported with the batteries. Basically, this is information is available everywhere. Just type in flywheel based UPS. You will get all the details. Basically, a flywheel will be running. It's a latest. It's not a latest technology for the software. It's a little technology for the software, but manufacturing industries in India are using from last 20 years. I can say. A flywheel keeps rotating when you have a grid power supply, and it stores kinetic energy. And when grid power fails, and before your generator kicks in, this flywheel will act as a battery for you. It can support you for 25-30 seconds, depending on 30-40 seconds, depending on your load conditions. And imagine, you will be using only 1/10 of the space required for installing a general standard UPS with batteries. And over and above, you don't require cooling, and you don't have to remove and dispose this hazardous, what is considered as a hazardous material once in 2.5 years. It's just a metal piece which is rotating, and it gives all the advantages of having UPS. And what I can say is we have gone ahead and done what we have done is, what I can say, entire campus is under UPS because the technology, because we had a capacity available. So end user in the campus, sitting in the building, they don't see power changeover at all. Dale will not understand, but we will understand. In the summer months, there will be a lot of grid power failures, but the entire power changeover happens at the generator room, and people don't see changeover at all. So it's 100% batteryless. As a maintenance engineer, I am very happy. Any maintenance engineer is very happy, because buying a battery, using a battery, and disposing a battery is a difficult task altogether. It's not that easy.
Great, Vivek. I think you have put a very interesting question now. Mr. Dell, I just to inform you, today we had Mr. Jayesh Ranjan, who is Principal Secretary, Industry, Commerce and Information Technology from Telangana State. And he made a comment Amazon has decided to put 3 data centers in Hyderabad and he has given a commitment. Like if anytime you start DG, you put a penalty on government. Okay, so thank you for that, making it more interesting. But now one last question, very interesting. I don't know who is the person. He has asked like air quality is becoming more and more polluted. Okay, it is increasing beyond limits, and you are asking for like free cooling. Where do you compensate?
Is this question for me or Dale?
It is for you, and Dell can also elaborate.
No. See, what I'll say is compared to running a DG and polluting, throwing all the smoke, everything into the air, using free cooling air to just to cool the data center is much better than anything else. We are not polluting the air. We are not adding smoke and other chemicals into the air. Just we are using the air to cool the servers, and it is getting back into the atmosphere in the same condition, except the change in the temperature, which gets adjusted. Nothing much damage we are doing to the air. This is much better compared to running, a DG and installing a UPS. Installing a UPS, say for our capacity, say 4,000 kVA, we might have used, say at least 1,500 batteries of huge capacity. So manufacturing, installing, disposing, compared to all this is a much better way of cooling the data center.
Now, I think the question would be, first of all, how long have you been operating the current data center with outside air, and how much increase in failure rates have you seen in your IT equipment?
It's to me, Dale.
Yes, yeah. How long has NetApps operated its data center in Bangalore with outside air, and then have you seen any increase in failure rates?
No, nothing, absolutely nothing I can say. It's running, last 3 years, we inaugurated our Bangalore campus in January 2017, and we are in 2020 now, coming to an end of 2020. What a year it was, 2020. So nothing much. Absolutely no. We were also worried in the beginning because we were new to this technology, and nobody had used it for the software. Nobody had used it for the data center. So we were all worried, but everything is running smoothly. It's what we can say. It's amazing technology. Only people has to take little risk, pay little extra money during the installation project stage. But once installed, it runs. Only minimum maintenance has to be done. After that, it runs for you. And it saves
I'll add that several companies will sell air-to-air heat exchangers. So if the air quality is a major concern for the data center, that's an option. And then moving towards liquid cooling, it's much easier to have an economizer cycle, and you can actually go to warmer outside air temperatures and still cool the data center efficiently. I think there was a presentation on immersion cooling today, and yesterday we talked a little bit about liquid cooling. So there's a trend towards liquid cooling, especially with higher density data centers. And there the issue of air quality is significantly reduced, and the fear factor tends to go away. Then there's a new fear factor of liquid in the data center. But here again, if you talk to the operators of liquid cooled data centers, you find that it's really an unfounded concern that there's really hasn't been problems of leaks and that sort of thing. But again, there's mitigation opportunities. You can use a non-conductive fluid and eliminate that risk completely.
It depends on culture of companies. Or some people are worried to bring the cooling liquid inside the data center. The people absolutely they do not agree for that. So it again depends.
So you'll take the outside air over the liquid.
Okay, so thank you very much, Dale, Mr. Vinod. I think you made the introduction very wonderful for everyone. Let me summarize the data center summit now. We are very happy to inform you that more than 1,230 participants had registered for this program from 28 countries. I think it's a great message for everyone. More than 730 registered participants had attended this event. Normally what happens, like there could be many registration, but there could be less conversion, there could be more conversion in the registration to like attendance. So we had like great participation. having more than 60-70% like virtual environment is like extremely wonderful now. We had 35 speakers from several countries. In fact, we are having Dell from USA. We had Kurt who spoke on like immersion cooling from USA. We had Terry who spoke on data center commissioning. Then we had one gentleman from France who spoke about like modularity versus energy efficiency in data center. I think we are really honored to have these distinguished speakers for this data center conference. We had excellent participation from government. Sri Sanjay Malhotra, who is who is additional secretary from Ministry of Power. He is a authority for authority for like energy conservation in the country, and chairman and managing director of REC Limited. He spoke a lot about like energy conservation. He has offered many things for like IGBC, IGBC, and LBNL. He also congratulated LBNL and IGBC for developing ECBC user guide. We had Mr. Jayesh Ranjan, Principal Secretary, Industry, Commerce and IT from Telangana government. He really appreciated the efforts put by IGBC and LBNL for developing the ECBC user guide, and there could be some good news to have like regulatory provision for like Telangana state to have ECBC adoption for it. Then we had Srimati Uma Chauhan, who is Director, Scientist G from Ministry of Electronics. She really appreciated the efforts put by IGBC and LBNL, and she also mentioned like there are more requirement for like awareness, and definitely we have given recommendations. She agreed to consider several recommendations. There would be separate call with her very soon after this program. We are extremely happy to thank Dell for all the excellent efforts put and leading energy efficiency in Indian data centers since 2010. Dell is like one authority for data center at international level to define the norms for energy efficiency in Indian data centers. There are few announcements. I would be happy to do that because this session is this is the last session to say goodbye to everyone. But I would like to mention like this program would be there on CII Hive platform till 27th of December. Any participant who has registered, not registered, they can do register again. They can see all the presentation from the day one till like last session. There is an option like watch later the session. They can see the session again and again. All the recordings will be downloaded within big time, and it will be shared with LBNL as well as will be uploaded on IGBC website. They can also see these recordings even after the session for 2 months or 3 months or like even next year. Thank you all the speakers, attendees, participant, AGM, and our 4 pillars, task force chairman. And finally, we would like to hear from Del Sartor to close and say goodbye to everyone.
Well, shoot, I thought I already did that, but I'll reiterate my thanks to you and the rest of the team at CII for offering the summit, and thank the participants for their valuable time, and hopefully everybody gained some information and lessons learned from the sharing of information. Thanks a lot.
Thank you, everyone. Thank you, Del. Have a pleasant day.
Thank you, Shiraj. Thank you, Del.
Namaste, Del.
Thanks.
Okay. Bye, everyone.
Bye.